Hi Algebra 2 students. This video is on the polynomial remainder theorem. So today in class you did an exploration where you kind of discovered what the polynomial remainder theorem was, and now I'm just going to kind of formalize that in the form of some notes. So we have a definition of the remainder theorem, which will be if f of x is a polynomial divided by x minus a. So that's kind of like the setup for the theorem. And then if you think about it symbolically, what that looks like would be something like f of x divided by x minus a. Then this theorem tells us that the remainder will be f of a, as in the value of the function when x is a. So I'm going to say over here that will be equal to, or rather we can conclude that the remainder will be equal to f of a. And something just to kind of pay attention to is that this form has a subtraction sign in it, the x minus a. So when you're kind of like extracting the value of a, it's always going to be the opposite of the sign you see in the equation or in the expression. So we're going to look at an example now. We have a function f of x, and we're going to think about what will the remainder be when we divide by x minus 1. So there's two ways we can think about it. The first way is we can actually do the division. So if I was going to divide here, well, because I could do synthetic division, right? Because it's of the form x plus or minus some number. So then I put the opposite sign outside of the synthetic division box, and then inside I'm putting the coefficients 3, -4, and 7. And quickly, if I do my synthetic division, multiplying 1 times 3, I get 3. Adding here, I get -1. Multiplying 1 times -1, I get -1, which when I add, I get 6 here. And then remember, this is the remainder. This would be the x to the 0 power term, and this would be the x term. So putting that all together, I get an expression, 3x minus 1 with a remainder of 6. And so that 6 is what I'm trying to think about right now, because the remainder theorem has to do with the remainder. So the remainder theorem says that that remainder of 6 should be the value of the function at a. So we should have the remainder equals f of, well, my a value here is going to be 1. I'm going to take the opposite sign. So the remainder should equal f of 1. So if I plug in 1 for my function, I get 3 times 1 squared minus 4 times 1 plus 7, which is 3 minus 4 plus 7, which is in fact 6. So I see that the value of the function is the same as the remainder, and I can kind of verify that the remainder theorem works. Now in this next example too, we're going to see how could we apply the remainder theorem to answer some questions. So here it says, find the remainder when f of x is divided by x minus 2. And so like first thing I'm going to kind of think about is that what is my a value here? And here a would be positive 2 because I'm excluding the negative sign. I'm taking the opposite sign of what I see. So then the idea would be that the remainder theorem tells me that the remainder will always be f of a. So f of 2 in this case. And I can save myself the trouble of actually dividing, though I could confirm with synthetic division. I'm not going to do that here. I'm just going to plug into my function and see what I get, and then I'll know that will be my remainder. Now, I'm going to do this by hand here, though if you have a graphing calculator, you could put the function with x's into y equals, and then take a look at the table and look at the value of the function when x is 2, and you'll get the same thing. So that will save you some time. So basically I'm just plugging in 2 for x. And now I'm just going to kind of simplify and see what I get. So 2 to the third is 8 times negative 3 will be negative 24. 2 squared is 4 times negative 4 is negative 16 plus 10 times 2 is 20 minus 7. So I know this is going to be negative 40 plus 20 minus 7, which is negative 20 minus 7, or negative 27. So then I know that my remainder will be negative 27. So in this next example 3, we have asking a slightly different question here. It says, is x minus 3 a factor of this long polynomial 2x to the fourth minus 11x to the third plus 15x squared plus 4x minus 12? Ooh. Well, the idea of it being a factor means that the remainder would be 0, because it means that x minus 3 times some other polynomial would equal this other long polynomial. So we have this kind of equivalent relationship between the radius being 0 and us having a factor, or it being a factor. Okay, so all I really need to see is the radius 0 here? Well, I know that the radius is going to be equal to the function value. I'm going to call it p of x. So the function value at a. Well, a here would be just the 3. So the remainder should equal what happens when I plug in 3 for x into this function. Again, I could save myself some time here by using the graphing calculator and putting this function into y equals. Now, I would highly recommend you take out a calculator at this point, because you're going to start dealing with some larger numbers. You could do it in your head, but you might just want to double check to make sure you're not making some mistake. But here, I know 3 to the fourth power is 81, so this is 2 times 81. And then 3 to the third power is 27. And then this would be plus 15 times 9 plus 4 times 3. Oh well, I might as well just write 12 at that point. That's 12, and then we have bring down that negative 12. Now, one thing I noticed right away is that positive 12 and negative 12 are going to cancel each other out. So I can kind of just peel that part away and kind of ignore it. And then I can continue with my simplification. So then I get 2 times 81, that's 162. Minus 11 times 27 is 297. And then 15 times 9 is 135. And so then if I add the 162 and the 135, I get, what do you know, I get 297. So I get 297 minus 297, which is in fact 0. So then I know, since the p of 3 is equal to the remainder, I now know that the remainder is 0, and therefore x minus 3 is a factor of, I'm going to call it p of x because I don't want to write it all again. So we're calling this function here p of x. Okay. So now I have one you-try problem for you guys to try on your own, and it says, what is the remainder when p of x is divided by x minus 5? So remember, you're like thinking about what is your a value, and the remainder should equal p of a.